All right, so let's talk distance. How does Google Maps find the distance between Upland and Huntington Beach? Well, there's a scale, but how do you think they find it?
Miles? They find it through points
And they connect them. So actually, this is kind of like not a fair question because you can talk about the distance from here to here, but when we drive, do we drive like that? So a map can find the distance straight from Upland to Huntington Beach, but you usually have to drive there, correct? All righty. All right, can the Cartesian plane, the Cartesian coordinate system, help us find the distance? So if it's the distance between here and here, what if I were to do this? Then could I find it? How? You'd have to connect all the lines. Like how? You'd have to turn it into a right triangle. Right? If this turned into a right triangle, would it matter if I drove west first and then south, or could I drive south first and then west? It wouldn't matter. You're still going to get there, right? As long as you don't drive east. Correct? All right, so this is the distance formula. We compare distances to the legs of a right triangle. So how many of you recognize these phrases right here, change in y and change in x? What do you remember it from? Graphing. Why? What do we use change in y and change in x with graphing? Yes. The skeleton. What did we use that skeleton for? Slope. Okay? So, we're going to do the same thing, only now the Pythagorean theorem says c squared equals a squared plus b squared. Well, wouldn't I say that this could be the a on my triangle? Correct? That would be my change in y. Wrong one. This is my a. Couldn't I say this is my a on my triangle? And this is my b on my triangle? So that would make my c on my triangle? If I did what? What do I do to find c? Well, what'd you guys do with the Pythagorean theorem? You squared this one, right? Still wrong color. I squared this one. Isn't that what I'm doing right here? Squaring it? Isn't that what I'm doing here? Squaring it. And I'd square this one. Correct? You add them together and you get the square of this one. Okay, so instead of calling it C now, the only thing we're going to change is we're going to call it D for distance. But we're going to use the exact same steps again. Okay, do you guys remember what this sign, this symbol is? It's called a delta. Delta x means change in x. Delta y means change in y. I don't understand what's so funny about that. Okay. All right, so let's look at an example. Find the distance from point A to point B. So if this is A and this is B, you guys don't need to write anything down yet. All right, couldn't I just count my change in x? I don't even need to know my coordinates, correct? I could just count them. To go from here to here, it's 1, 2, 3, 4. So the change in x is 4. What's my change in y? 1, 2, 3, 4. So d squared would equal 16 plus 16. Instead of writing 32, wouldn't it be easy to say that it's 2 16ths? Why would I write that? Because when I take the square root, that 16 simplifies into 4 root 2. Let's also approximate. If it was 16 times 2 is 32, what's 32 almost the square of? 36. So what's the square root of 36? So this is almost 6, so it's going to be 5 point what? Awesome, 5.7. That'll work. Questions?
Well, which one's the answer?
They both are. This is the exact answer. This is the approximated answer.
Which one do you want? Like,
Both. I want both. Good question. Okay, let's look at some more. How far is it from UHS to McDonald's? Okay, let's be a little mature. I'm trying to use something real life, okay, to make a point. So, d squared. What is the change in x? The change in x would be that green line, right? What's my change in x? Count it. 1, 2, 3, 4, 5. 5 squared, right? Because this would be a square, correct? 5 squared plus, what's my change in y? 2 squared. It's like a 2 squared. Okay, see that? Which is going to give us 25 plus 4, right? There's 4 in there and there's 25 in here. So d squared equals 29. I'm not going to be able to simplify that anymore, right? That's really messy, and this is the one I'm going to save. D squared equals 29. 25 and 4? Oh, between 25 and 36. And I can't make 29 into simplified square root anymore, right? So what did you guys say your estimate is? 5.4 seems reasonable. Alrighty. Questions? Okay, I don't think you need to write this one down. Let's just keep going.
wait, what was the exact answer?
What I need to you can't simplify 29 anymore. Right?
You can't, like, you just square root of 25 and 4.
That's how I got 29.
Oh.
25 plus 4 is 29, and then I took the square root of both sides, and there's nothing, I can't simplify this anymore, but I can estimate it.
Square root of, like, 25 and 4.
You can't do it separate. Mm-mm. You can't do it separate. They're together. Okay? Alrighty, let's do this one quickly together. Not on whiteboards, but together. Alright, so what's my change in x? I think instead of doing this one, I think I'm going to keep going, because I really want to hit this. Okay, so pencils down. So this is the really fun distance formula. This is x squared minus x2 minus x1 plus squared plus y sub 2 minus y sub 1. Doesn't that look like a lot like your slope? y2 minus y1 over x2 minus x1, but I didn't teach it that way, so you didn't have me first semester. What did I do for y2 minus y1? You guys remember? Instead of writing y2 minus y1, what did we call that? Give you a hint. Change in y. Good. This was my change in y. And this one was my change in x. I'm going to do it both ways, and then you guys are going to decide which one you'd rather do. All right, so here are my x values. Here's an x, and here's an x. We're going to work backwards. -3 and -1. -3 and 1. What's the difference between -3 and 1? What do I write for distance? Jesse, what do I write for distance? What goes in between these? A negative sign. Distance is different, right? What about here? What are my y's? I have 4 and 8. We need to find the distance between 4 and 8. What's going to go in here? A negative sign. All right, I'm going to do it the other way. Tell me how far it is between 1 and negative 3. If you were to do it on a number line like we did in our warm-up. How far is it to go from negative 3 back to 0 and then plus 1? 4. And how far is it to get from 8 to 4? 4. I didn't need any fancy formulas and a y2 minus a y1 and a negative sign. I don't need any of that. You can just count. How far is it to get from negative 3 to 1, right? Can somebody tell me what negative 3, thank you, what is negative 3 minus negative 1? No. Do you see what I'm saying? Some of you get confused with this, right? What is negative 3 and negative 1? Negative 4. What do I have here? I don't have a negative. Is that going to matter? Why? I'm going to square it anyways. So if you have a negative and you square it, the negative doesn't matter. So this is negative 4 squared, which is the same thing as 16, right? So I have 16 plus 16, isn't that 2 16ths? Correct? Which is really what? 4 root 2, which is really, what's our approximation for that? Okay, so here are the steps. These are the classic steps. Identify x and y values, use your distance formula, find change in x and change in y, substitute and simplify. I'm not going to do this right here, this step. If you've been taught this and you want to use x2 minus x1 and y2 minus y1, that's fine with me. I'm going to use change in x and change in y. And I'm going to do it for every single one of them. I would like you to copy this down. Okay, so pencils down. You guys don't need to write this right now. Mrs. Wiz's golf ball is much closer to the hole than Mrs. Mahler's golf ball. How far apart are they? Let's see. If I want to go from here to here, how would I do that? All right, well, I'm going to identify my points first. I've got negative 2, comma 3, and I've got 8, negative 20, correct? I'm going to do distance formula and Pythagorean theorem all at the same time here. So, distance squared equals, do you guys like this way better? Where it looks like Pythagorean theorem, like this, and take the square root at the end, or would you rather see the square root first? Square root, I think it's easier to do the square root. They're the same thing, right? Okay. So d squared equals my change in x. What did I do last time with the change in x? Red. The change in x squared and the change in y squared. And what do we do with those changes? We add them and then we take the square root. Correct? All right. So it says the exact same thing in the homework, yeah? All right. So what is my change in x? Think of a number line. Visualize a number line in your head. How far is it to get from negative 2 to 8? 10. Does everybody see that? If you had a number line and you started at negative 2 and you wanted to go all the way to 8, there's a 0, isn't that 10 away? You guys see that? Good. All right. How far is it from 3 to negative 20? 23. Right, that's just like our thermometer here, isn't it? Exactly like the thermometer here. What we did in the very beginning on that warm-up. You were at negative 20, right? is up to 3. Actually, I don't think the numbers are the same. There's 28 and 4, which would be 32. Same concept, right? You're at negative 20. You got to go all the way up to 0, which is 20 degrees, and then 3 more, which is 23 degrees. Same exact thing. If I'm at 3 or if I'm at negative 20, it doesn't really matter which one I go first. I'm finding the difference between them, right? So negative 20 to 3 is rise up 20 and then 3 more. Negatives don't matter. Why don't they matter? You're going to square it anyways. Isn't a negative times a negative a positive? Okay, so let's do the hard part. D squared equals, I'm going to add these together. So this would be 100 plus, well, 3 squared is 9, so it's going to end in 9. 529. So D squared, why are my D's so messy right now? D squared equals 629. Do you guys know that magic number that's close to 629? No, not from doing all those.
Oh, yeah. Oh, 18.
No. 25 is 625. 25 squared is 625. So, 3 squared is 629 is my correct answer. My approximated value would be 25 point, I'm guessing 1. That's pretty close to 625, right? Remember, I want both. Questions? I would like you to copy that down now. You don't have to draw this. You can just copy this right here. Alright, I'm not going to make you guys do this with whiteboards. I just want you to watch me. Okay? Who would like to do x sub 2 minus x sub 1? If you'd like to, feel free. I'm not going to. Alright, so where is here's my x's. 2 and 5. What's the difference between 2 and 5? Isn't that the difference between the two numbers? Well, let's find the difference. What's the difference between 2 and 5? 3 squared. You know what, let's do this. I'm going to put the change in x in here. That way just nobody gets mad at me, other teachers. And that's what I'm finding, the change in x, right? So this is 3 squared. And what's this one? 2 to negative 1. How far does it to go from 2 to negative 1? 3, right? You got to go 2 spaces to 0, and then you got to go 1 more space to negative 1. Change in y. Adding them together. So isn't this 9 plus 9? Or just Jesse? What? No, it was Frankie. Who asked me how I was going to do that? I don't remember. So 3 squared, oh, it was Frankie. 3 squared is 9, right? So 9 plus 9? Isn't 9 plus 9 just 2 9s? Right? Correct? Aren't there 2 9s in there?
Wait, how do you have 3 squared? The blue.
Because the difference between 2 and negative 1 is 3. Correct? So what is 2 9s? No. Oh, gotcha. What is 2 9s? Well, how do I simplify that? 3 root 2. And what would I approximate that as? Matt? Because 18 is a little over 16. 4.2. Okay. Do you guys need to copy this one down as well? Okay. We'll let some people copy it down. All right, guys. I'm going to go through these pretty quickly. I need you to write down, please. What is the difference between negative 3 and negative 6? No, not negative 3. What's the difference between negative 3 and negative 6 if you were to count on a number line? 3. And what is the I need the talking to stop, please. What is the change in y between negative 5 and negative 4? 1. So what is that? 9 plus 1 is 10. Can I simplify that anymore? So let's approximate it. What would that be?
That'd be between,
3.1? Something like that? Whoa.
yeah. No. I think it's 3 points. Oh, yeah.
3.1. Question. Pretty easy, huh? Isn't this so much easier than x2 minus x1 plus y2 minus y1? It's exactly the same. All right, let's try this one. This one's a little trickier. 5, 4, 3, 2, 1. The talking needs to stop. What is the change in x? How far is it between -7 and -7? 0. How far is it between 2 and -6? 8. Right? You're not always adding. You're finding the difference between them. Right? You're not always adding. What's the difference between 1 and 2? Philip, what's the difference between 1 and 2? If I would have added it, what would have been? 3, and you wouldn't have got the right answer. No, you find the difference between them. You think about a number line and you find the difference. It's like counting up. Frankie? No. You want to owe me 10 minutes? Yes. Okay, then that's my answer. So 0 squared plus 8 squared is just 8 squared, which is 8. Distance would be 8. You're more than welcome to draw it and draw yourself boxes. That's fine, but you don't really need to, right? Yeah. Let's draw it. -7 to 2. 1, 2, 3, 4, 5, 6, 7. 1, 2. There's the first point. And the second point is -7, 6. 1, 2, 3, 4, 5, 6. If I want to draw myself a triangle, how would I do that? I'm sorry?
The homework looks like?
This one's a harder one to draw. Yeah, it's exactly what the homework looks like. Let me do it out this one. It's easier to see. Okay, so -3, -5. 1, 2, 3. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. How would I find the distance between this and this? I would draw myself a triangle. See that? What's the change in y? Right here? 1, isn't that what we have? And what's the change in x? 3, isn't that what we have? Alright, fantastic. How are the Pythagorean theorem and the distance formula related?
Because
How are they related? They both use the change in y and the change in x. Just one of them you're counting and one of them you're using a subtraction method. Same thing. Okay, will you ever get a negative, guys, will you ever get a negative answer using the distance formula? No. Explain.
because you always square it.
Because you always square it. Good job. Good job, guys.